This video will cover the topic of a geometry review. Be sure the date and topic are at the top of your page. The essential question to guide this video will be, what formulas and strategies do we need to know to solve geometry problems? And we've covered a lot of information in this unit, so this video is going to help us have it all in one place. Let's start with perimeter. And of course, perimeter is when we are calculating the distance around a shape. So we're figuring out the linear measurement around a particular shape. And of course, we will come across perimeter in real life in many ways. Things like fencing, whether you're fencing a yard or a garden or whatever the case may be, maybe the tile along the edge of a room or a picture frame. Those are all things that you would be describing with perimeter. And we find the value of the perimeter by simply measuring all of the sides and adding up their total. So for example, if you had this rectangle, you would add up 5 plus 2 plus 5 plus 2 to get your total perimeter of 14 units. And if we were adding up this triangle, we would say 4 plus 3 plus 5, which would of course be 12 units. And notice these aren't units squared or units cubed, they're just linear units. And in contrast to perimeter, we also talked about area. An area is what fills the space of a 2D shape. And just like we did with perimeter, we certainly see area in real life quite a bit. And we see it in things like how large a house is. We measure that with square feet. We measure that with area. How much carpet you would need to lay down, how much space you have to plant a garden or whatever the case may be. Those are all things of area. And as for how we calculate area, that depends on what shape we're talking about. Rectangles, triangles, parallelograms, they're different rules. For a rectangle, we would just multiply the base times the height, or you'll see it also as length times width. So that would mean, for example, in this picture here, right, our base or our length is 4, our height is 2, and we just multiply that together, and this is in units squared. So it's how many little squares there are. For a triangle, of course, it's a little different. We take that base times height, and then we divide it by 2, because we're looking for half the space. So that means in this triangle, we would do our base times our height, meeting here at a nice right angle, and that would be 8, but we'd cut it in half, and our total would be 4 units squared. And we cut it in half because this would be our whole rectangle, like we saw previously, but we just want half that space. And our parallelogram is just another version of a rectangle, so that is still just base times height. So once again, we look for the base and the height by looking for that right angle, and so our area would just be 4 times 2, or once again, 8 units squared. So the area, of course, depends on each figure, but we basically are finding the inside space of the shape. And we use area to also find the surface area of a shape, which is when we want to find this space that covers all the sides of a multi-sided 3D object. And we see surface area if we are frosting a cake or painting all the walls of a room or wrapping a present or building a box. Those are all examples of surface area. And no matter what 3D object we're talking about, finding the surface area is always the same. We find the area of all the sides and add them together. So if we had this rectangular prism, we would find the value of all of the faces. For example, the bottom here would be a 4 by 5 rectangle. And I would find all of my faces and find the total. Go ahead and fill that in for yourself. I'm going to do it as well, and we'll kind of make sure we get the same answer. But see what you get when you try it. How'd you do? Hopefully all of these faces are the same as mine. And then the total, if we added them all up, would be 76, and it would be in units squared because it's still a type of area. And let's do the same with a quick reminder of a triangular prism. Same exact rule, we're finding the area of each face. Just be mindful of the fact that 2 of your faces here are going to be triangles. So when you find that area, you have to use your triangle rule. So I wrote down all 6 face options. Obviously there are only 5 faces, so you'll be leaving one of them blank. But go ahead and fill in what you've got, and we'll see if we agree on our answer. How'd we do? Hopefully we have the same 5 values. We might have looked at it at a different orientation and they might be in slightly different spots, but regardless, that means when we add it all up, we should get the same surface area, which I found to be 30 units squared. Which brings us finally to volume, and that of course is the space that fills the inside of a 3D shape. And we see volume all over the place. We talk about anything that's getting filled has to do with volume, so a pool or a bag of food like popcorn or candy, or the amount of sand that a sandbox can hold. All of these are volume. And for all prisms, this is just for prisms, I should make that clear. For all prisms, you multiply the area of that base layer by the height. Which means, for example, if we were working on a rectangular prism, we would find this rectangle base, which is 2 times 3, or 6. And then we would take our base and multiply it by our height, and so our volume would be 12 units cubed. And this time we're using that cubed to show that it's a 3-dimensional space that we are filling. Whereas in our triangular prism, right, we would still find the area of this base. You can look at it on either side here. And you would do that by doing your base times height of that triangle divided by 2, and 6 divided by 2 is 3. And then you would take that and multiply it by the height of the entire shape, which of course would be also 12 units cubed. And we can use that rule for all sorts of different prisms. I'm just showing you here the rectangular and triangular ones, but there are cylinders that we'll talk about later, and certainly other forms of prisms. But the essential question for this video was just to kind of have a review of what formulas and strategies we need to know to solve geometry problems. Hopefully this was a good overview. You have all your notes in one place, and this will help you as we move forward.